How was our universe born? And if this seems hard to answer, then how about this? What was before our universe? While scientists are looking for the answer to the most difficult question in history, let's find out what they've come up with so far. In the 20th century, we've shed the light on this mystery, all thanks to this man, Edwin Hubble. One day on Mount Wilson in Southern California, he aimed his telescope at the sky and found out that these random clouds of gas flying everywhere are actually other galaxies, and there are a lot of them. And also, he learned something else, something that changed the world forever. They're moving. So what, you may ask? Well, it meant one very important thing. The universe is expanding, and if it's expanding, then it probably had a beginning somewhere, right? Now, all we have to do is run time backwards and see where the beginning was. It took the scientists many more years to come up with a full-fledged theory, the Big Bang Theory, and here it is. Nothing has ever been anywhere because neither when nor where existed. Do you get it? But actually, no. There was one thing. It was the so-called cosmic singularity, a state of our universe in which it was incredibly small, dense, and very hot. Imagine if our universe was compressed into a small ball. The pressure and temperature inside would be enormous. At some point, it became impossible to withstand them. And here comes the Big Bang. It was an outburst of energy and matter that created everything we see now. Time and space, basic physical forces. It also scattered quarks everywhere. These quarks, tiny particles that make up our world, were all boiling in an incredibly hot cosmic broth. When it cooled down, gravity began to attract them to each other. They gathered into atoms, then molecules, and then into the first objects into the world, stars. And all this happened just some 12 to 14 billion years ago. Alright, now we know how our universe was created, but what was before that? Alan Harvey Guth, an American theoretical physicist and cosmologist, has devoted his whole life to solving this mystery. After learning about the Big Bang Theory, Guth found some flaws in it. For example, the distribution of matter was very even, although it shouldn't have been. Let's hang a balloon filled with paint to the ceiling and lay a white canvas on the floor. If we drop the balloon down, it will burst and we'll see absolute chaos on the canvas. A bunch of spots scattered everywhere randomly. Neither is like the other. But that's not really what the universe looked like. Instead of throwing a colored ball from the ceiling, let's draw a small red dot on the canvas. Now, let's expand it a little more, and capture this all on frame-by-frame shooting. We'll see a circle gradually growing in all directions. That's the reality. The early universe was very even and proportional. That was Guth's discovery, the theory of inflation. Here's what it says. Even before the Big Bang, there was some kind of force that could give the bang a strong acceleration, something that was able to distribute everything in space instantly and evenly. Guth's theory was a success, and now most scientists rely on it. For most of them, this idea of the birth of the universe is quite enough. For most, but not for all. Martin Buewald is a German professor of physics, and, in his opinion, the universe was born quite differently. Remember when we talked about cosmic singularity? The state of the universe in which it was small, infinitely dense, and super hot. According to Martin's theory, the singularity couldn't just appear out of nowhere. This is nonsense. But then, where did it come from? Let's look at a pendulum on an old clock. The pendulum rotates back and forth. Its movement is smooth, continuous, and non-stop. This is how we usually see time. It flows and never stops. But quantum time, quantum time doesn't work that way. It's more like the second hand of a clock. it consists of small segments and makes short pauses. And, just like with the second hand of a clock, the beginning of one segment of time is always the end of another. See what I'm getting at? Let's go back to balloons again. According to the Big Bang Theory, once upon a time, our universe began to expand, inflate like a balloon. But sooner or later, it will blow away back. The universe will start shrinking and return to the state of cosmic singularity. And then guess what? The Big Bang too. Nothing appears out of nowhere and disappears into nowhere. According to Buewald's theory, the beginning of each universe is the end of the previous one. Our universe is not at all the first and not the last. Millions of similar universes existed before us and will exist after us. This theory, although it sounds very logical, is far from complete. Unfortunately, we don't have enough knowledge to find all the evidence for it, so for now, all this is just a hypothesis. But some people come up with even stranger ideas. Scientists promote such unusual theories that no one could even think of. Neil Turk, a South African physicist, and his colleague Paul Steinhardt, an American theoretical physicist, look for answers far beyond our universe. They say that yes, our universe isn't the first one. There have been and will be an infinite number of them. And not only will there be endless Big Bangs, our universe is just one of an infinite number of others. And all of us are stuck in a cycle of endless rebirths of parallel worlds. This sounds incredible and frightening at the same time. But how does it work? According to this theory, our universe is located inside a so-called brain, as in membrane. In other words, we're stuck in some kind of elastic surface that's capable of contracting, stretching, oscillating, and so on. Like pieces of fabric on a rope, these parallel universes are located near each other. Each one has a neighbor. We're not the exception. Another universe may be an inch from ours, but we can't see it. That's because there's a tiny space between us, and this tiny space contains the fourth dimension. How do these universes originate? Through brain collision. These brains are getting closer to each other very, very slowly, until one day they finally collide. Their collision creates two Big Bangs and two parallel universes. Then they're moving away from each other. The created worlds continue to live. We're currently at this stage. But when they disappear, the brains collide again. And this will lead to the birth of a new universe. Remember the inflation theory? There was a mysterious energy that pushed and accelerated the Big Bang. Well, if we did collide with another universe, that would explain everything. Of course, everything described here is a great simplification. When you hear that our world is some piece of fabric on a rope, it sounds like complete nonsense. But this idea is based on string theory and M theory, two giants of quantum mechanics. If they turn out to be true, they could explain almost everything in our universe. Creating a theory is an incredibly huge process. Turk and Steinhardt made a huge amount of calculations and swept away many, many non-working theories. Also, to work this out, they have to overcome the limits of the human mind and think in 11 dimensions at once. Unfortunately, this crazy and elegant idea was laughed at. Turk and Steinhardt say that scientists are regular people, just like everyone else. They're also afraid of change and the unknown. And it's really scary to question everything we once believed in. Many years ago, people didn't believe that the Earth was round. Then they were outraged by the Big Bang Theory. We can't make discoveries without struggle and fear. That's why Turk and Steinhardt don't plan to give up so easily. After all, the evidence that we have now only says that each of the three theories is equally possible. So which answer is correct? We may never know, at least not at this stage of human development. Unfortunately, as long as we have no evidence, we can only theorize. But maybe one day we'll find something that will open our eyes once and for all. Maybe one day we'll solve the mystery of how our universe came to be.
Bang. That's how it all started, around 13.8 billion years ago, and was figured out over the past 100 years. Everything we see in space today – planets, asteroids, comets, stars – it wasn't there at the beginning. In the 1920s, astronomers came up with the idea of how a long time ago, the universe was just a single point. An extremely hot, like trillions of degrees hot, compact, dense point that stretched and expanded unimaginably fast. Matter that started flying in all directions at the speed of light at one particular moment. The Big Bang was complete chaos, with teeny-tiny particles that were mixed with energy and light. Yes, a total mess, but still, in the first minute after the Big Bang, the base for everything that would later appear was almost finished. It was hot only during this huge blast. As soon as the expansion started, the universe began to cool down, similar to when gas cools when you spray it from an aerosol can. During that process, part of the energy kind of froze out, just like the water freezes into ice. Here, pure energy got frozen and solidified into matter. 1 minute after the bang, the cooling thing was still going on, extremely fast and literally everywhere at once, since the universe really doesn't have edges. It wasn't just a compact dot anymore. The base for further expansion and all that's coming was being formed. Remember those tiny particles from that first boom stage of the universe? They started grouping together, which formed atoms of helium and hydrogen. It took about 3 minutes for most of the helium and all of the hydrogen in space to be made. These two are the most common elements and the basic materials that later formed the first galaxies and stars. Just because the base wasn't finished doesn't mean the creation of the universe stopped after those first couple of minutes. True, after that, no new elements were created for millions of years, which is why the initial version of the universe was entirely helium, hydrogen, and energy. But eventually, atoms began to slowly group together, which, after lots and lots of time, caused the creation of galaxies and stars. Clouds of helium and hydrogen grouped and turned into stars that had gravitational forces. Our sun is also made of 3/4 hydrogen, while the rest is helium. 1/4? Yeah. At later stages, some other, heavier elements started to show up too, such as carbon, iron, oxygen, and so on. It wasn't all about chemical processes where new elements, stars, or planets kept coming. The whole universe has been expanding ever since the Big Bang. Researchers realized other galaxies are kind of moving away from ours. Guys, you need to stop doing that. How will we discover alien life out there if you keep running away all the time? And not just that. The farthest galaxies are actually moving quicker than the ones closer to our galaxy, the Milky Way. The universe is fabulous, unknown, mysterious, scary, and completely silent. Imagine yourself floating in your spacesuit somewhere above Earth. All you could actually hear is the sound of your own breathing, nothing from out there. Since there's no atmosphere, sound doesn't have a way to travel or be heard. Speaking of spacesuit, that thing costs around $12 million. I guess that means we'll have to wait up a little bit more to try that whole chilling in space thing. Mercury is the closest planet to the Sun, so you might think it's the hottest one too. And yet, Venus actually takes the title of the hottest planet in our solar system, with the surface baked by a temperature of 840 degrees Fahrenheit. Fair enough. Mercury doesn't have an atmosphere, which is in charge of regulating temperature, so it loses the race for the title of the hottie of the solar system. Venus also has pretty long days. Just one takes around 243 Earth days. Now that comes in handy for those people with pretty long to-do lists, who like to take it easy and slow. However, Venus orbits the Sun in 225 Earth days, which means 1 year there lasts 18 days less than a Venus day. You can have 2 birthdays in 1 day then? Well, 2 birthdays in a day could be one of the good sides, but the downside is that on Venus, it rains sulfuric acid and snows metal. Not so fun anymore, huh? The Earth is cool itself. Being 4.5 billion years old and the only known planet that supports life, it also has more trees than there are stars in the Milky Way. 3 trillion, while there are only 100 to 400 billion stars. We may have counted trees, but still, so little do we know about our ocean. only 5% of it is explored, so we know less about it than about Mars or the Moon, whose surfaces have been fully mapped. It's funny how outer space is just 62 miles away from us, counting from above sea level on our planet. Seems so close, I sometimes go that distance just to have my breakfast. And yet, only 5% of the universe is visible from Earth. 68% of it is dark energy, while 27% is dark matter, which we can't see with a telescope. So close, yet so far. We will always see the same side of the Moon, no matter where we are on Earth. The Moon rotates on its axis at the same speed it orbits the Earth. This is called synchronous rotation. Sunsets on Mars are blue. That happens because the fine dust on the red planet has the size perfect for blue light to efficiently penetrate the atmosphere of Mars. So the blue light scatters, after which it stays closer to the direction the sun goes, unlike the light of other colors. The universe is full of wonders, and one of them is a planet made of diamonds. Yay! It's twice bigger than the Earth, and scientists believe it's mostly covered in diamond and graphite. Now to get there, you might probably need that $12 million spacesuit, together with a really expensive ship. But if, and that's the key word here, you manage to go there and back, you may even easily pay it off. Scientists also have some predictions as to the end of everything. Oh boy, ready for this? At its early stages, the whole universe was dense and compact, so it was really thick. But after around 400,000 years, it kept expanding, which made it more transparent. All of this encouraged releasing light we know today as the cosmic microwave background, or CMB. It's like if you turn your TV on an empty channel and switch off the cable, you'll see the static black and white dots moving on your screen. There's something like the CMB, and also an afterglow of all that energy that was released during the Big Bang. CMB is still here. Astronomers can see it through the microwave telescope. Expanding never actually stopped. The universe is still spreading every second at an unbelievable speed, causing all the objects in space to move away from each other all the time. How repelling. We know it because the sun from other galaxies appears redder than it's supposed to be. This is called redshift, and it happens when the source of light moves further from the one who's observing it. Then there's gravity. It attracts all objects in the universe to each other, which is the reason why planets keep orbiting the sun, or why our solar system orbits the center of the Milky Way. It's why we stay on the ground, while in space we'd float since there's no gravity up there. Having all this in mind, scientists got the idea that one day the universe will simply take the opposite direction and start shrinking back, which will be known as the Big Crunch. Whether this really happens depends on the type of our universe. If it's open, it'll keep expanding and nothing will ever stop it. But over time, as it's stretching, the density will become so low, galaxies won't be able to form new stars, and the existing ones will fade away. When space loses all the light and heat, life won't be possible. The universe will just remain as a cold beyond, which will keep spreading thinly into endless darkness. And then, Big Crunch or not, bang! It all disappears. Hey, good thing we have billions of years ahead of us, huh? Well, maybe you. I won't be around then. I'm going to retire.
We fly away from Earth to look at it from a distance. It glows like a holiday tree. Big cities look like yellow spots at night, and during the day, we see strange structures, like a palm tree-shaped island in the UAE, or a dark band that runs all the way through China, the Great Wall. These are traces of human existence. Now let's point our telescope at other planets. Mars, it's just an empty, endless desert. Venus, only rocks and volcanoes. Even if we look into distant space, all the planets out there are deserted and lifeless. Not a single trace of an extraterrestrial civilization. Many people are convinced that life on Earth isn't unique at all. Here's our galaxy. There are billions of sun-like stars. And here is the entire observable universe with billions of such galaxies. There's an almost infinite number of stars, and near each of them, there may be habitable worlds. But we may not have found life on other planets because it hides from us under the surface. For example, there's Europa, a satellite of Jupiter, slightly smaller than our moon. Its structure resembles a soft-boiled egg. Its surface is a hard crust of ice, but if you take a big enough drill, you can get to the liquid yolk, an ocean of water. Jupiter and its satellites are very far from the sun, so it's quite cold there, about 270 degrees below zero. So liquid water instantly turns to ice. But Jupiter has a strong gravitational force that causes a lot of friction inside Europa, and its core heats up. The heat melts the ice, and we have a watery ocean under the surface. Water is the foundation of all life, so there could be simple bacteria in that ocean. And who knows, maybe there are other life forms out there. For example, weirdly shaped fish. Because of the weak gravity, their bodies are built differently, or something like whales feeding on plankton. In 2009, scientists found a planet that is completely covered by an ocean, GJ 1214. It's about 40 light years from Earth, and about 75% of its mass is water. Still, the temperatures on this planet are so high that water evaporates and takes the form of super liquid water. There's so much steam that it feels as thick as water itself. No life could exist in such conditions. But scientists have recently found at least 24 planets better than Earth and called them superhabitable. These planets orbit distant stars in their habitable zone. It's the sweet spot at a perfect distance from the star. In our solar system, Venus, Earth, and Mars are in this zone. A superhabitable planet must be 10% larger than Earth and have stronger gravity. That way, it can have a denser atmosphere. A temperature 8 degrees higher than on Earth would make the planet more humid. This would encourage a variety of living organisms there. These planets may be great for life, but it's hard to tell if there is life there already. The main marker that would confirm the existence of an advanced civilization there might be radio waves. Imagine a habitable planet similar to Earth. In the process of evolution, intelligent beings appeared there, like humans. They're much taller because of low gravity, and their eyes are adapted to the light from another star, much brighter than the sun. Sooner or later, this civilization will have to use radio waves to communicate with each other. We can think of these waves as loud sound from speakers. Here's Earth. We're now actively using radio waves, and the noise coming from our planet is pretty serious. If a neighboring planet had radio telescopes, big dishes that catch these waves, they would realize that life is blooming here. There are many radio telescopes on Earth that are pointed into distant space, waiting for a signal from aliens. But we haven't received anything yet. Still, that doesn't mean there isn't a planet somewhere in the universe that emits radio waves. It's all about distance. We're jumping 200 light years to another star. Suppose there's a planet X where life exists. The civilization here is advanced enough to use radio waves, so they release the first wave into space. Our radio telescopes won't be able to pick it up until 200 years later. This also works the other way around. Radio communication on Earth has only existed since 1895. Our radio signal won't reach Planet X until 2095, and only then the aliens will hear our voice. But this radio noise doesn't stay for long. Every year, our technology improves, and our radio noise decreases. We're beginning to use mobile communication, cable TV, and fiber optics. This all reduces the volume of our planet in the radio spectrum, and soon it will simply become invisible to other planets. The same thing is happening on the other side. So, the radio waves coming from civilizations are a brief blip on the cosmic scale, and we can't accept radio silence as proof that extraterrestrial life doesn't exist. A giant telescope, which could take a direct photo of a possibly inhabited planet, would change the situation. We zoom in on the photo, and there it is! We see alien cities with tall buildings and lots of antennas. But now, we can't look that far away. We can take pictures of Mars and its satellites, and even their quality misleads us. For example, Cydonia. It looks just like a human face on Mars. We thought there used to be an ancient civilization there that made some sort of sculpture or memorial. More extravagant theories said it was the remains of a giant human, and there's a whole body of it under the sands of Mars. But in fact, it was just a hill. Strong winds blew out some hollows there, and when there was a shadow in those hollows, we took them for human eyes and a mouth. Or a monolith on Mars' satellite Phobos. We found a smooth rock there that was almost as tall as the pyramid of Cheops. The news has spawned many theories about the civilization that built it, but it turned out to be no more than a rock. The infinite number of stars and worlds around them almost guarantees the existence of other civilizations, so why wouldn't they come to Earth, right? We think that life throughout the universe develops in similar scenarios. The emergence of simple life forms, followed by evolution and growth of a technologically advanced civilization. But, just like on Earth, cataclysms happen there too, causing mass extinctions. Meteorites, for example. Perhaps there was a civilization out there ready to go into outer space, but a huge meteorite, like the one that wiped the dinosaurs off the Earth's surface, made that civilization disappear, and life on that planet began a new cycle from scratch. In addition, the more advanced the civilization, the greater the risk of its self-destruction. Scientists might conduct experiments in machines like the Large Hadron Collider and accidentally create a black hole there. It would begin to swallow everything around it and grow in size. Soon, all the super-developed cities of this civilization and the entire planet would simply disappear. Another possibility for super-advanced civilizations is to travel through wormholes. Those are tunnels in space-time between universes. Aliens might travel through them and lose interest in going back. But it's also possible that life on Earth is unique. That's because our planet was formed thanks to a number of incredible coincidences. The first is the location of our solar system in the galaxy. In the Milky Way, there are constant fireworks of exploding supernovae. The radiation from these explosions destroys everything around it at great distances. Our solar system is right in the sweet spot of the galactic orbit where we're safe from such explosions. Another factor is the moon. One theory of the formation of the moon says that about 4.5 billion years ago, a meteorite the size of Mars crashed into us. If the impact had been straight, the Earth would have just broken apart. And if that meteorite had only scratched the Earth, the pieces would have just flown away. But the collision occurred precisely so that part of the meteorite remained in Earth's orbit and formed the moon. Then, the moon stabilized the Earth's rotation and heated our core with gravity. Only then, our planet developed a magnetic field, which protects us from the solar wind. Other scientists believe that life outside Earth may be biochemically different. Carbon and water are the basis of our bodies, but carbon could be replaced with silicon or phosphorus, and water could be replaced with ammonia or methane. These atoms could form molecules of different shapes and perhaps assemble into a living organism. Life based on such elements would be unlike anything seen on Earth.